2.4 least common multiples. I can find least common multiple.
Here's the key question. Thank you, Hudayfa. Can you all find least common multiple?
Yes.
Good. Those of you that did these notes on Friday, hopefully that practice yesterday refreshed your memory. And those of you that were with me yesterday, hopefully you're like, hey, I totally get this. Okay, key. It's on the cheat poll. A multiple is different than a factor. A multiple is different than a factor. Someone explain the difference in a very loud voice. The difference between a factor and a multiple. Don.
A factor is dividing, and finding a multiple is multiplying.
Okay, finding a multiple is multiplying, a factor is dividing. Sure. Somebody else looking at the cheat poll, what else have we said? And you don't have to use the cheat poll's words, you can use your own. Ayana, loud.
A factor is the same or less than the given number, and a multiple is the same or greater than the given number.
Okay, good. So if I give you like the number 16, anything that is below the number 16 is a what? Anything that is less, let me rephrase that. Anything that is less than 16 is a what?
Factor.
Factor. And anything that is greater than 16 is a what?
Multiple.
What if it is 16? What if the number is 16? What is it then, Ayub?
It could be both.
It could be a factor or it could be a multiple, right? Does that make sense? So these are factors if it's less. These are multiples if it's more. Is that okay? We could almost maybe write that in our cheat poll if that would help. You guys like that visualization?
Yeah.
In a multiplication problem, we have factors and multiples at the same time. The multiple is the what? The multiple is the what?
8.
What is that fancy word though? It's not always going to be 8, it's going to be the answer to a multiplication problem, which is a what? Product. And then the numbers being multiplied are going to be the
Factors.
factors. Hello, I'm up here. Why are my eyes not up here on your notes? Least common multiple then. We are comparing, or we are finding the smallest number, or the smallest multiple that two or more numbers have in common. Yes, no?
Yes.
Okay. So that's how we find multiples. You simply multiply by another number. So if I want to find all the multiples of 2, I multiply by 1, 2, 3, 4, 5. I can keep going forever and ever, couldn't I?
Yes.
If I want to find the multiples of 1 billion, I multiply by 1, 2, 3, 4, and so on and so forth, right? Okay? So when we found multiples, we did what? What did we put around the multiples?
A box.
A box, right? And we said it's probably a smart idea to always find the first multiples of any given number, right? So multiply by 1, then multiply by 2, then multiply by 3, and so on. You got me?
Yes.
Now, if you want to find the least common multiple of two numbers, we just do what we just talked about. You find the multiples of the first number, you find the multiples of the second number. And our strategy was to put a box around both of them, right?
Yes.
How many should we start with? How many should we find of each number, everybody?
5.
So to find 5, you multiply by 1, by 2, by 3, by 4, by 5, right?
Yes.
After you have all of your multiples found for both numbers, we start slashing. If there's a 4 here, is there a 4 on the other side?
No.
So we slash it. There's an 8 on the left side, is there an 8 on the right side?
No.
Slash it. There's a 12 on the left side, is there a 12 on the right side?
Yes.
Circle it. Are we done?
Yes.
That is the smallest multiple that both those numbers have in common. Yes, no?
Yes.
Okay?
Yes.
Trying to wrap this up. Whoever's whistling, stop. Down here, we found the first 5 common multiples for 3 and 7, but as you can see, we crossed off this one because there was nothing on the other side that it had in common. We crossed off this one, this one, this one, and this one. Yes, no?
Yes.
Nothing was in common. So then what did we have to do?
So,
Add
We found 3 more. And why do we find 3 more over here? Why do we find 3 more on this side?
Because it's the smaller
Wait,
number.
raise your hand. I need someone to come on. Why?
Because it was the smaller number.
Because this number was only at 15, right? 3 times 5 was 15. This number was at 35. So we wanted to see if there's something between 15 and 35 that worked, right? So we started with whatever we had the smallest multiples for. Yes or no?
Yes.
Cece, did you get all that? I'm up here. Questions before we stop?